Welcome to Tuners Subaru Training Part 22. In this training tutorial, we're going to be taking a look at the basics of spark timing. We're going to understand how spark timing relates within the Otto cycle, and then how we're going to be working with it in programming within HP Tuners. We have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at understanding the fundamentals behind spark timing in our training tutorial. We're going to take a further look at spark timing and knock control specific to the Subaru ECUs in our next few training tutorials, but we need to understand the basics here in getting started and working with spark timing. Now, let's jump in here and take a look at a spark timing table. We're going to talk about what the values represent, the load axes to the table, and then breaking this down with a video demonstration of how the Otto cycle is going to work within the spark timing reference. So it's going to make a lot more sense of the values in the table and what they actually mean. Instead of trying to explain it, it's better to see a visual demonstration. So let's jump in here. I'm going to work with a Subaru STI file here. It doesn't matter if you're a WRX or STI file that you're going to be taking a look at. I have that open. We're going to jump right now into my engine section here, and then we're going to move into the area called Spark, and we have our advanced section, we have a retard section, a coil dwell section, and then a knock sensor section. We're going to be focusing on only our advanced section right here, and specifically just the main spark timing table in this tutorial. So if we go down here under base, we find we have our 4 different tables. This is going to be representing our TGVs open or closed, and whether the engine is in a warm-up mode or already warmed up. Now in this case, we're just going to look at our base table right here. Again, we're going to get into the specifics of what all this represents and what all this means, including our knock control in the next tutorial. We want to take things slow so you understand one thing at a time here. Let's pop open our table and let's start to take a look. Now in our main spark timing table, this is where we command the spark timing from, and you might not understand what spark timing is going to represent or what it's going to mean. The values in the table here are where we want to fire off our spark plug on the compression stroke. So we have our intake stroke, we have our compression stroke, we have our power stroke, and we have our exhaust stroke on a 4-stroke Otto cycle engine. Now, the values in our table here are going to represent where we want to fire that spark plug out, but these are going to be specific. These are values before top dead center, so degrees before top dead center. What does that mean? Well, if we're looking at our Otto cycle, we traditionally call the point where we're starting off on the intake stroke, that's traditionally 0 degrees. And if we go and we have our piston travel downwards to bottom dead center between intake and compression stroke, we're going to call that 180 degrees. And then as we move up to the top dead center between our compression and power stroke, we traditionally call that 360 degrees. And then if we go from our power stroke to our exhaust stroke, that's going to be the 540 degree marker. And then as we come back up from the exhaust stroke to the intake stroke, that's going to complete 720 degrees of rotation of the engine to complete one Otto cycle. Now, when we're talking about spark timing, we're going to be referencing things within the Otto cycle a little bit differently. We're going to call the TDC point between our compression and our power stroke 0 degrees. And then when we're referencing our spark timing, these are degrees before top dead center. So if we're looking at something like 49 degrees, that means that we're telling the spark plug to fire off 49 degrees before the piston reaches the top dead center mark between our compression and our power stroke. So these values represent where we want to fire the spark plug at. Now, it's specific of the values of why they're set up this way in the table. I'll talk about that in just a little bit. Let's dig in here to what the axes mean to the table. Now, looking at our load axes, this is going to be an engine load grams per rev. The grams per rev value here is a mathematical function of the air mass ingested into the engine. So we know that if we're looking at a mass airflow sensor, that's going to be registering in terms of grams per second. Now, in order to determine the grams per rev value, to determine a load, that's going to be the grams per second air mass value multiplied by 60 and then divided by engine RPM. And that gets us our value here of grams per rev. Now, for reference sake, if we're at idle conditions, we'll be around 0.3, 0.4 grams per rev. When we're driving in part throttle cruise conditions, we can be anywhere between 0.3 to about 1.1 grams per rev. Now, as we start to get into boost and into higher throttle angles, we'll find that we can be here anywhere between 1.3 and to 2.9 or higher in our grams per rev. So the grams per rev is a function of the air mass ingested into the engine, also the engine speed. As our boost picks up, as our airflow or air mass picks up into the engine, we'll find that the grams per rev starts to ascend. As we're driving at very light part throttle conditions, the grams per rev will go down because the air mass is going to be less because the throttle angle in the engine is going to be open less. So that's the idea here behind our engine load grams per rev. Now, the top axis here is engine speed. If we're looking at this, we can see it's going between 800 and 6,800. So we're finding here the table is this three-dimensional table. It's a composite table with all these various spark timing amounts of where we want to fire the spark plug off. Now, this looks confusing if you're just starting to get familiar with spark timing and tuning. Let's take a look at a video demonstration so this makes a little bit more sense in terms of the values that we're starting to command in here. So looking at our video demo here, this is going to have our intake valve, our exhaust. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.